I was supposed to present in Hyderabad, but for some reason I couldn't actually be there for health reason. So let's get started to my topic, like starting slow to move faster. So what I actually mean. So basically, we all are actually from different companies, tech companies. We especially build softwares or services for others. And one of the core thing that we always feel is that we are not doing things properly. So our project fails, sometimes due to budget, sometimes due to quality. We couldn't make the timelines, so many issues. And there is a kind of like common saying that IT project fails almost like 80% still. And the reason is that most of the time when we are working in a company, we know where we are making the mistakes and we know how to improve it. But the problem is that there is always a dilemma, or there's a kind of like hesitation from the organization, like whether we should be doing that or not. And one of the common ground where we actually have this hesitation, or you can say dilemma most, is actually the agile engineering practices. So I found many companies across the world, especially in our part of the world, like Southeast Asia, that we know that these are the best practices, but still we are not, kind of like getting into those practices. We are kind of like hesitant that, okay, we should not actually go there. So in my talk, I'll try to actually bring out the dilemmas we have and actually where we are actually getting it wrong, and are we going to achieve if we actually follow the agile engineering practices, and the case compared to where we are not following agile engineering practices in an organization. So as Ishan said, told me about me. So I'm just a simple agile coach who's actually learning almost every day. And what I am trying to do is that trying to kind of like spread the agile engineering practices knowledge to everywhere, and kind of like doing the advocacy for agile engineering practices. And hopefully in this part of the world, I will be actually successful to actually implement that work in an organization where we are building solution either for us or for our clients. And most of the time, what our company wants is that whatever project you are working on, we should be quick to market. So we have an idea for being competent, or you can say the competition that we have with others, we must actually go to market quickly. And as a result, there's immense pressure from the companies to the engineering team that we need to build something quickly. Then something the companies want, I think most business people will agree, is ROI, return on investment. Like, yeah, we are investing on the team, whether we are getting the right return or not. And this is actually kind of like key factor for companies to actually invest on something. Another thing our companies want is have it like your development cost should be minimized as much as possible. And when you are actually trying to minimize the development cost, we are actually trying to maximize the profit. And also we want MVP, the minimum viable product, and happy customer. So in a nutshell, our companies want everything on their favor. And how they do it? They actually have these sort of things: fixed features, fixed deadline, fixed budget, and fixed resources. And we all know what actually happens next. They still fail for it. So we couldn't complete the project on time. We couldn't finish things. And the reason is that why is actually happening. So if you look at this, this is actually a simple statistic, stats from 2005. Like, what are the reasons that software project fails? And if you look at number 4, it says insufficient time allocated for testing. That is 32% reason why the software project fails. And then we have at the bottom that immature dev tools and application platforms. And just above that, we have time constraint and premature software releases. So these are the actual reason why software project fails over the across the globe, like why is happening. And the reason, if I kind of like show you why, it will be surprised that this is actually a similar statistics. If you look at 2006, the red line actually shows the extreme programming, and extreme programming is actually one of the core base for agile engineering practices, and it used to be very high compared to what it is used to be now. And if you see, the red line is actually declining. So we are actually gradually moving away from these core practices of extreme programming, whether we are talking about pair programming, whether we are actually doing this code reviews and other things. So we are actually getting away from these core practices. And as a result, we are having some more problems. And what we have actually gained on top of that, we are actually increasing the DevOps practices is quite new. We are getting into continuous integration processes. The progress is not that steady, but one thing that we gain over years is the Scrum practices. The Scrum practice is going up, but our extreme programming practices, which is actually the engineering practices, is actually going down. And it shows that most of the companies, like Agile methodologists, we have this 52% of people are using Scrum, which is actually a good framework for whole product development, not only for engineering. But if you look at the other part, the extreme programming, XP, or the Scrum and XP hybrid one, the percentage is very low. So it shows that, yeah, we are actually more focused on the delivery, but we are actually not focusing on the core engineering practices. And this is something is a very much worrying factor. Now, if we are talking about agile engineering practices, there are so many things, but I want to actually go through few of the points. First of all, pair programming, then TDD, BDD, and ATDD. Then we'll have this code review and refactoring. We have CICD, and then DevOps and SRE. Now let's talk about pair programming. And one of the most common problem with the companies, and I can tell you, like in Bangladesh, out of say 50 companies, if I ask them if they do pair programming, I will say around 48 or 49 will say that they don't, practice pair programming. And they have a reason. The reason is waste of time. Why two people will work on same feature, same time? Is simply waste of time. They says that increases our development cost. Sometimes pair programming can create internal conflicts between developers, and also it decreases productivity because multiple people's working are on the same feature. And that's actually a common dilemma most of the companies have. And I, as an agile coach, when I go to different companies and talk to them and ask them the reason why you are actually not doing it, it's the common thing. Like, yeah, why we should do it is kind of like, increasing our development cost. But the actual benefit, if you look at the chart below, you can see that there's a real test case that there are two different tests took place, where one particular group of students were written code alone, another particular group of students were written code in a pair. And if they actually did multiple iteration, and what they found is that the number of test cases passed by solo student was much lower compared to the one where we use this pair programming, the pair of students working together. So maybe in terms of quantity, it was low, but in terms of quality, it was always high. And there's a reason why it happens. The reason is that when we're actually having this pair programming, say as a developer, I will make 10 mistakes. But when I'm working with another developer who would have made 8 mistakes on the same feature, when we are actually working together, we are finding each other mistakes. And there will be some areas like this gray areas where we can actually find the mistake. It can be, a common thing to happen that both of us missed a point, but that will be much lower than the number 10 and number 8 mistakes that we would have made individually. So as a result, though we are spending same time, two resources on the same thing, it's actually helping us to increase the code quality and the reduced bugs. Then we have this common practice called test-driven development, behavior-driven development, and acceptance test-driven development. Many of the companies are actually not used to these things. And again, the first thing we always talk about is this is time consuming. And because whenever we are doing the test driven development, first we have to actually write those test cases, like what are the test scripts that we are going to run for ATTD. For unit testing, we have to write the fail test case first, then do the actual development. So it consumes time. And our companies, as they want things faster, they always say that, okay, you don't need to do it now. We can do it later on. And unfortunately, that later on never comes. So that's first thing, the time consuming part. We do not have expertise. That's another thing. Yeah, we know about unit testing, but we didn't do it before, or maybe we don't know how to actually handle these unit tests, or BDD in some corner cases, or some remote resources, how to utilize it. So we don't know it, so we don't use it. Then again, if it's time consuming, it requires more resources. We don't have budget. And most common thing about it is that we do not have the right mindset. And when I say right mindset, that means like quality first. So if you are not focusing on quality, then you might actually skip the whole idea of TDD practices. An actual benefit, like if you are actually following TDD, the points they are missing is that they are reducing the technical debt. So lots of technical debt can happen in different way, and we'll talk about it later on. We can have faster releases. We can have maintenance. We can ease on maintenance part. We have lower bugs. We have higher quality and transparency. So that's actually important. But unfortunately, we still have a dilemma that we know this thing. I know most of you know that what are the benefits of things, but still we have this dilemma. Same things goes with the code review and refactoring. Like, again, we do not have time for that because code review and refactoring takes time. And when you are talking about refactoring, it's more time consuming than the review part, because we are continuously improving our code. We are continuously fixing things or improving our existing features through refactoring. We are fixing bugs and everything. What we do is that during the maintenance mode or the iteration, we are fixing bugs. We are adding new feature, but we are not doing the refactoring properly. And as a result, our technical debt is actually increasing. And sometimes we might think, yeah, really we do we need refactoring, or what, our code is working, so no need to look at that. So usually companies actually don't give us this extra time for refactoring and improving our code or code reviews. Some of the companies, they do it once in a month. Some of them do, say, once in a quarter. They are not a regular event, the code review. Some companies do it properly, but most of the companies actually ignores it. And as we all know, this whole TDD cycle, we have this red, green refactor. So what it says is that whenever you write code, you always make sure that you have these options. You first write a failing test case, that's red. You write the enough code to pass it as a green. Then you do the refactoring. You optimize it, you clean it up, you add new feature, or you remove something. Whatever you do, any changes in the code, you go again back to the cycle, do a red, green refactor. And most of the developers, they know about these terms, but they do not practice it because they do not have enough support from the organization. And if you do code reviews and refactoring, there are lots of benefits, and I just put few of them, like better code, quality product, and product actually evolves iteratively. And we can ensure standard against a checklist, like when you're doing code review, what are the things that you are following? So we can make sure that, yeah, whenever the code review is happening, we are maintaining a standard by following a checklist across the project. Now, the next is CICD. That's a quite new term, the continuous integration and continuous deployment or delivery. So again, there's a dilemma from the companies that, yeah, this is an extra cost because we need to hire experts. Developers usually don't, they are not that much expert in this CI/CD concept. So we have to hire some specialist skilled people, and they are not available. So you have to spend extra. So no need. Initially, big investment on development time for infrastructure, like we need to have the servers, these processes and everything. and it eventually slows down the project to start with. So that's actually another problem of the companies, that yeah, let's do it manually. We just develop something, we release manually, we do not need this whole CI/CD pipeline or everything. And sometimes team might not feel comfortable, like, yeah, I'm doing something, is going through the CI/CD pipeline, something is breaking, and I am looking, kind of like a bad example in the company, that yeah, whenever I develop something, it breaks the production system or the staging system, so it's better I will not be part of that. So team comfort level is one of the reason many companies do not follow this CI/CD process. So the whole thing is that still the first thing they are worried about is the cost and time. So that's another big dilemma. But actually the benefits are much bigger. I know it will be a little bit slow when we are actually first developing the product. It will be a little slow, but it will actually ensure you transparency. It will ensure you instant feedback. It will ensure that we have more quality when we are releasing the product, because we have all the checklists, and we also have this process automated. So we do not need manual intervention, or it's not like that we release something and after some time clients comes back, or our users comes back to us saying that, hey, there's a mistake in the solution. So we can find those things automatically most of the time. And DevOps and SRE, those are the two new terms we all are, kind of like following. And most of the time, it's kind of like a hype going on regarding the DevOps and practices. So we are hiring DevOps guys to actually automate our processes, making, our releases more frequent, more, transparent and everything. And still there are some dilemmas, like, yeah, we don't have the readiness. We are not ready to adopt DevOps culture. So that's actually a big dilemma in many of the companies. Another thing is like, it's, time consuming process. So when you are actually having the whole DevOps pipeline setting, the whole flow setting, it's a time consuming process. Required investment, definitely. You need to invest in the infrastructure. You have to invest on the skill set, everything. And the last one is the missing expertise. Like, companies do not, want to jump into something that they are not, completely sure that they can handle properly. And if you look at the job board, you can see lots of DevOps related job posts are there, and they are offering higher salaries, because that's actually one of the missing expertise part in the tech industry, the great DevOps guys who can work with the infrastructure as a code, or build infrastructure, build these pipelines, make the whole process smoother. So that's the dilemma, but the benefits are actually faster delivery, we have more transparency, we have continuous feedback, and we have quality delivery. So we know about the benefits, but still the companies, it's very hard to convince them. Now, when we are not doing these agile practices, what is actually happening in the back? So we are actually increasing our technical debt. Now, what is the technical debt? The answer is that, like, sometimes what we do is that we all use credit cards, most of us. So what we do, we actually kind of like spending something that is not ours. So we take loan from bank, or spending from our credit card, we buy things, we have our luxury lifestyle. But what happens if we do not pay? Say end of the month, we get the credit card bill or our loan installment. And if we don't pay, then what will happen? Maybe we miss one payment, maybe we miss two payments. After three payment, you will get notice from the bank, or maybe legal action from the bank that you are not paying. They will call you almost every day, and you can't actually escape the debt. You have to pay it back. Same thing happens when we are developing technical projects. So what we do, we know that, okay, we are following agile practices, we are doing test-driven development, we are doing everything fine, but suddenly we have a management pressure that, okay, I know you guys are doing great, the right things, but we need to deliver it, say, next week rather than next month. We need to deliver it next week. So whatever you do, please stop doing this test-driven development or this, code reviews and everything. Just release it as it is. And that's where the technical debt happens, that we are taking a shortcut from our standard practice, which will ensure the optimal quality. And we are just, in order to meet the deadline, we are just taking a simple shortcut. And that's where the technical debt occurs in software development. And what will happen? As our time grows, say when the project is actually, say, 6 months or 1 year project, you'll see that our technical debt will grow over time. And in some cases, if you're not following the engineering practices, it will grow exponentially, like it will grow really fast. And the problem is that when technical debt grows, our velocity reduces. And that's actually a big problem. So if you look at this chart, you can see that sprint 1, we have some great, user stories done. So we have a good velocity, but very little technical depth. Sprint 2, we have good velocity, but still the technical depth has risen a little bit. Sprint 3, 4, fine. In sprint 4, actually, we have more technical depth than actual sprint work. That means when we are having this technical depth, we are actually spending more time to fix things than actual doing something new. And if it continues, you will see from the chart that your technical debt will accumulate more time than actual sprint work. And this is actually a real case. I'll show a simple chart from my team in over the last couple of years, that what we actually seen, where we are actually having this problem. And there are something like, if you are having a technical debt, as per Martin Fowler, he's told that if you know that you are doing something wrong, but you know the consequences and you want to come back and fix it, then that's a good one. We call it a prudent technical debt, or we know about it's a deliberate. So this quadrant, we call it the Martin Fowler debt quadrant, is a good one. But most of the cases, what we do is that we are not sure about, what we are doing and why we are doing it, and we are not kind of like no intention. We do not have any intention to know that where we are actually making the mistakes. So that's a kind of like recklessness that, I don't care whatever I'm doing, as long as it's working, my client is happy, I'm fine. Even though I don't know the term properly, I do not know how the system, things work properly, I just did something and it works. That's actually recklessness. And these sort of technical debts are actually really bad, and we call them ignorance debt. So these are the things that can actually harm you. And this is a real case study from one of my companies that I worked with last 1 year. So we actually used to have a 2-week sprint, and we had these 2 teams with similar team members and working on the same product, but different team and different features. So basically, one of the team was very kind of like religious, that they will do all the agile engineering practices like TDD, they will have the CICD. And there are another team who was like, yeah, we will do it like a traditional way. We are not going to follow this TDD approaches. We will have manual testing and everything. We'll have this CICD, but our part will be actually the part where we can control when we want to release. It's not actually completely automated. And we kind of like mapped this performance, like how it's actually done. So when we started, you can see the clear comparison. The team without agile practices, they were delivering more at the beginning. And those who are having these agile practices, they were actually delivering less, and comparatively very less, almost like 50% lesser. And as the sprint grew, the left team who are actually doing the agile without agile practices, their performance was going down. So this is actually the 60, 65s are the velocity. So we call it story points. So these story points are actually going down. And at the end of the almost like 6 months, like 12 weeks, what we saw is that the team who are not following the agile practices, they are actually producing less, because whenever they're building something, they are working on a new feature, they have to go back and make sure that nothing is broken from the old part. They have to do this manual testing from the very beginning and make sure all the cases are, ran manually. They know that it's working, then they will do the release. But the other team who are actually following the agile practices, they are doing TDD, they are doing automated testing, they have this code review and everything, they actually improve their velocity and they are producing more. And the whole comparison is that the team spending more time fixing bugs on the left than adding new features, whereas on the team right, they're doing both very fast, because when they're shipping something, they already know that whether something is working or not. And this is a real scenario over a period of 6 months that we ran, and then we actually moved the other team to Agile Engineering Practices, that you guys should also follow that. It was kind of like a litmus test for us, like whether we should be doing it or we should not be doing it. Because from the management, it's just kind of like a statement to the management that you look at the data, and data don't lie unless you kind of like fake it, or you kind of like manipulate it. But this is the real data, what we actually achieved from two different teams, like an A/B testing, and this is the result. Now you decide which way to go. And the management then decide, yeah, we should be giving more time. And if you look at the trend on the right side, you'll see that the team actually started slow, very slow compared to the team on left. But they are actually moving faster, because after a certain time, you will be done with your basic things like this whole CI/CD pipeline, your DevOps structuring part. You have this whole TD practices, your code coverages is automated. You can know the defect density, everything is automated. So it will actually give you more time to actually finish more user stories or fixing bugs, because you already have the support from the automation that you have done. So you are actually starting slow, but you are moving faster in the long run. And that's actually the topic of our the discussion, that we should start slow, but once we start slow, do all these agile engineering practices, maybe we'll be not getting the expected result, like a quick delivery or quick to market, but in the long run it will actually help us. And as I said, automation drives agile, so the whole automation part will be actually driven by agile. And there are two things. What we do is that many of us actually know about this manual testing approach. We call it manual or exploratory testing. So Agile says that there are two shapes. One is the cone ice cream shape, like we call ice cream cone, and another was is the pyramid shape. So what happened is a cone ice cream is that the cone shape, you have the ice cream on the top, which is a big piece, and if you go, it's kind of like an inverted pyramid. Like the lower portion is kind of like thinner, and the upper part is a little bigger. So what we do in general practice is that we do very less unit test, in some cases 0 unit test in many companies. And we do a little bit more about integration test and component test or acceptance test. And then we try to do lots of automated GUI tests like Selenium. That's actually one of the most popular, UI testing tool. So we do this, GUI test automatically. And after that, we have a pretty bigger chunk of manual and exploratory testing. That's actually something we do. But if you look at the chart, you can see that this manual testing and other things will require more time and effort, but is not higher ROI. It will ensure lower ROI, because if you are giving more time and effort to something, definitely it will cost you more. And that's actually will ensure that no, you are not getting the highest return. Where if we go to agile, we can say that if we invert the cone shape to a pyramid shape, then what will happen? We'll be spending more time on unit test, or you can say the TDD, where developers will be writing more test cases. They will make sure like they're kind of like focusing all these concepts we have, like right bicep, like where we are want to ensure that we are doing the right testing, we are having these boundary conditions tested, all the exceptions and other things are actually tested. So unit test will be written by the developer. They will be giving more effort to test driven development. And then since we are giving a lot of effort in the unit test, the integration test will actually come a bit down, or acceptance test, because it's like one thing, like if you have a car, there are hundreds and thousands of components in car. So unit test will ensure that each of the components actually works properly. Now, if each of the component works properly, then we can have little test that, okay, whether integratedly they can work properly. So logically, the integration test will be simpler if all the components are working properly. But if you do not test each of the components, then your integration test will be much bigger effort than the individual tests. And once we are done with this acceptance test, like this, we have this acceptance test is done, then the automated GUI test will be minimized, because we know in the underlying fact, the integration is working, the acceptance criteria has been met. So the automated GUI test, or the UI test, will be actually much smaller. And that will also reduce the whole manual and exploratory testing part, that we don't have to give an lot of time for the manual testing. So that's actually something we need to do. So this is something Agile can help us. And sometimes, like, this is actually a funny cartoon. We know we are doing wrong, but if sometimes someone asks to help us, like, yeah, why not you change the tire, wheel, and you will be going faster. But as a team or as a company, what we say is that, no thanks, we are busy because we are doing work, and that is what it counts. The problem is that we are actually doing the work in a wrong way, because maybe changing this will take little time, but once you have added those changes, it will actually make you to move faster. And that is where the companies are missing. For them, if we follow these agile practices like CICD, DevOps culture, if we are following pair programming, we are doing code review, refactoring religiously means like we are doing it every regular basis. It's not like once in a blue moon we are doing this. If you are doing it regularly, you are making it a habit, you are making it a disciplined development, then you might get slower start, but in the long run, it will be much faster. You can move much faster. You have more transparency, like what is going wrong. You have more control of the deliverables. You have more, kind of like transparency regarding the prediction, like what and when we can actually deliver, how much we can deliver. And overall, your whole defect density will be much lesser. So you can actually find lesser bugs after the release, because most of the issues will be caught during the development once you actually have this process automation. And most of the companies, especially in Bangladesh, there are pretty big QA teams, like quality assurance team. So there are companies where we have 1:1, QA. So one developer, one QA, because lots of works are there. And we have a pretty big QA team who are doing manual testing all the time. And we develop the product, they test it, in between we miss lots of things. And once we release the product, we get, issues coming up. Client is not happy with the work. They are not paying for these bug fixes, because they want is a kind of like, it's our liability to actually fix those bugs, because we created it, intentionally or unintentionally. So these sort of problems will always come. And in order to actually, kind of like reduce these issues, we must have this kind of like understanding, the mindset that agile engineering practices is not bad. It is good. And our engineering team should follow those practices. And if we follow those practices, maybe you will be initially a little bit slower, but it will help you in the long run. So don't look at the quick, kind of like result. It will be a bigger result in the long run. And even we have to invest some time and efforts, but it's good for the project. Now, one of the question can be, do I have to follow all the agile practices? Like, say, I don't want to, maybe I like TDD, but I do not want to follow CICD or say DevOps part. The good part is that, yeah, you can pick your own way. Say, if you are comfortable with TDD and say code review, that's fine. If you want to pick the, CICD part, that you do not have time for the TDD or budget for the TDD, but still you want to do the CICD, maybe you can have a better, pipeline with better output or outcome with the TDD help. Because if you don't have the automated tests, then what's the point of actually doing the continuous integration and deployment. So we must have those supporting stuff. So my suggestion would be, at least we must be doing this TDD practices. We must have this practice of pair programming, and you can actually use pair programming as a immediate or instant code review as well, because when two guys are working together, they can actually see what's been doing wrong, and that's actually something we should be doing. And there another concept called mob programming. So if you're doing mob programming where everyone is actually implementing one feature at a time and working together, there is a good chance that we do not need the code review as a separate event, because in that particular event, the code review is also done, because your code is being observed by the whole team, and they can actually suggest how to write the code or what we should be doing as a collaborative way. So whatever tools or whatever practices that you want to adopt, you can. And my suggestion would be, start slow. Don't try to actually implement everything at a time. Pick your practices, start with it, and let the organization understand that there might be some, slow deliveries. There might be some, issues regarding the velocity, because you'll have some low velocity as you are following lots of practices. Those are the standards, and that's something we should be actually following. And what we say is that in Agile, quality is fixed. So in a traditional project, what we do is that we have a fixed feature and we have variables, 3 variables. We call it that budget, the timeline, and resources. And we have quality in between somewhere, which is kind of like fixed and flexible, both, like the variable. So what we do is that since our we have fixed our feature, now most of the clients want fixed budget project and fixed timeline project. Now, in order to give the product in a fixed timeline with fixed budget and fixed feature, what we do, we play with the quality. So what we ensure is that the quality is as low as possible, because quality requires more effort and more money. But in Agile, unfortunately, the time, the budget, and the quality is fixed. The only thing we play with Agile is the feature. So that means like we are not going to do everything, but whatever we do, it will be full of quality. So the client will decide that which feature they want. And that's how we, organize our product backlog in a prioritized way, so that if we miss something from our product backlog, our time is over, our budget is over, we have the less significant items at the bottom, which might not be required for the product at this moment. So that's how Agile helps. And my suggestion would be to everyone is that convince your organization and those who are actually part of the management team that it's really nice to go slow with Agile practices to actually move faster in the future. So that's it from me. I hope there are people who have some questions, definitely. So I'd like to actually know your point of view.
Thank you so much, Mizan. It was an amazing session from you. I hope people and all the attendees as well enjoy the session as much as I did. So as Mizan asked, any questions from the attendees, please post it on the chat, or you can post it on the Q&A section as well. And Mizan, we already have a question actually pending from an anonymous attendee. Didn't mention his name. His question was posted on the Q&A section. He asked, how can we apply TDD, test-driven development, for end-to-end testing, system integration testing? His question was.
Okay, so the good part is like when you say TDD, that's actually test-driven development. And one of the things over the years, what we did is that when we are talking about TDD, we are always thinking only about unit test. But TDD is actually an approach where we are doing the test-driven approach first. Now, when you are doing end-to-end testing, the problem is that we do end-to-end testing once everything is done. We can't actually do an end-to-end testing before something is done. Like where in TDD, we're writing unit test even before the code has been delivered or code has been written. So we write the fail test case, we know it will fail, then we write the code to satisfy the failed test case to make it a success, the green part. For end-to-end testing, you are actually talking about ATDD, the acceptance test driven development. So most of the end-to-end testing, we call it ATTD. And the tools that we use mostly are Selenium is there. There is Appium for app testing. There are lots of other testing tools available. One of the recent one that I've been teaching in my CSD class is WebDriver.io. So that's actually something similar to Selenium, but it's a nice tool for end-to-end testing. But only problem with that is that you can write the end-to-end test cases like the expected behavior of the software beginning, but in order to make it a test, like whether it's working or not, you have to wait until the feature has been ready. So the basic difference is that when you're doing end-to-end testing or say GUI-based testing, what will happen is that you can write the end-to-end test cases before. How? Like if you have worked with Scrum, there is we call the user stories. That's not a core practice of Scrum, but that's also an extreme programming practice, XP practices. We took the user story concept from there and we utilize it. And there is 3C in the user stories. We call card, confirmation, and conversation. When you're talking about the confirmation, we are actually talking about the acceptance criteria. So when we know about the acceptance criteria, you can actually start writing the end-to-end test cases. Like say if you're using Selenium, you know what are the expected behaviors, how it's going to work, and you can actually start writing it. But you have to wait till the program feature has been implemented to test it. Because if the developer hasn't developed it, there is no way you can actually do the end-to-end testing. So the whole concept of TDD, ATDD, so I would put end-to-end testing on ATDD part, because that's kind of like when you are doing this whole journey together, the acceptance test, like you doing this, then you are doing this. So, and there are some lots of frameworks available. And still, we need to do manual testing because, for example, when you're doing Selenium, you can do everything, form submission, you are checking this, that, link works or not. But one thing we don't do is that, for example, there is a simple CSS thing break, like the responsiveness is not working on your device. We can't actually check those things automatically yet, like, okay, this is breaking, this is not showing properly, the proportion is not right, so it has to change. That's why we still need some manual testing. So I hope I answered your question. If you have any counter questions, you can actually ask, or additional questions.
Sure. Thank you, Mizan. We have same anonymous attendee. He is asking to that same question is asking. I'm referring to a scenario where multiple systems are integrating, and when do those tests get executed? Does it happen in the end after all sprints are over and a separate team is required to do this? That is his question.
Yeah, okay, that's a good question. So actually, that's kind of like how you are planning to do. For example, if you have a CI/CD pipeline designed, like whenever you push a code to Git, it will be automatically built, it will be tested, it will be released in your staging or production in some cases if there is no issue. Now, the question is that this test, like when we are doing this automation, like the unit test case will be ran first just to make sure that, yeah, all the units are working fine. That is done. Then we move to next and we do the end-to-end testing. That's also part of automation. And the question is like, do I need wait till the end of the sprint? That's up to your team, up to your pipeline definition, how you want to define it. There are many companies, like I used to work in a company 5 years back. They had a strict rule. You can commit, everything will be on staging, but we are not pushing it in production. So what we used to do, there was only one release per day, and it used to be in the midnight. So our QA team will run the end-to-end testing manually. If they're satisfied, then they will actually release the product end of the day. But the last 3 years, the company I've been working, we have this instant releases. So whenever you develop something, it will be, the CI/CD pipeline is defined that way, that it will run all the unit test cases. If it's successful, move to the next one. If it's failing, it will come back to the developer. At the end, we are doing the end-to-end testing automatically. And if it's successful, then we are releasing it to the production. Now, many teams can actually have a separate team for that. Like manual, we always prefer, some human intervention over there, like to check themselves whether it's working or not. So definitely you can have a separate team, but regarding when to do it, I think it's up to your CI/CD pipeline policy or company release policy, how you want to do it. But my suggestion would be, If you automated it, if you do it instantly or frequently, it's better.
Okay. Well, our attendee is thanking you for this answer. Okay. So moving on to the next question, Mizan, we have it from Natarajan. He's asking any best practices for Kanban team. The team mostly works in production issues.
Okay, so if you look at the interesting fact is that when you are working as a Scrum team or a Kanban team, we are not actually talking about the which framework you are using. So I didn't talk about Scrum or Kanban because we are talking about the core Agile practices, the core engineering practices, and most of the core engineering practices are being actually kind of like copied or borrowed from XP and other best practices. So if you are using Kanban, I think you can still do the same, because the whole CI/CD pipeline, it doesn't depend on whether you are in a Scrum environment or a Kanban environment. You do something, you follow the practices, whether it's a CI/CD, whether it's a test-driven development, you can still do with Kanban. The only difference is that in Scrum, we have the time boxing part where we at least have a 1 week or 2 week or whatever the timeline we have decided. We have some sort of time boxing so that we can actually work on different things at the same time. In Kanban, what team is doing is that working on a very specific items in a regular basis. So they don't have this 2 weeks time boxing or 3 weeks time boxing or 4 weeks time boxing. They pick the card, they develop it, they release it, move to next card. So if you're following Kanban, I think it applies the same because it's not restricted to Scrum or Kanban.
Okay. Thank you, Mizan. Thank you for answering this question. So we have a few more questions lined up. And the next question comes from Asim. The question is, how tough is regression in CICD?
There are some challenges, like how you're actually going to do it. That's actually the main thing. But there are some good tools for regression testing as well. I think one of the core concept of the mindset of DevOps concept was that how much we can actually automate. The automation is one of the thing. So regression, I do not think that will be that much tough, but still it can depend on your products and services, the way you design. So if you are actually designing a solution, say in a legacy system, that can be hard. Everything can be hard. Even doing test-driven development in a legacy system or moving to a CI/CD can be a challenging part in legacy system. If you are moving to microservice architecture, where things are much decentralized, things becomes much easier. But regression again becomes tougher. So there are lots of consideration. So CI/CD can help you automate the whole thing, but the regression part for CI/CD, I do not think it will be tougher. There are lots of tools available, lots of practices, best practices available. So you can actually go through those. And if you still have any sort of like a guideline, like you need a guideline on how to do CI/CD for regression test, just ping me separately. I will actually give you more guideline or detail, not like how to set up this whole CI/CD process for regression testing, and what sort of challenges that you are going to face, and what sort of solution that you need to actually fix those problems. So I think we lost Ishan. So let's wait for him to come. Is Ishan coming? So QA, do you have anything, question? Okay, great. So Asim, I will come back to you on that. It's no problem. That's great. So which ones, so thanks Suman for the questions, like the practices you mentioned, which ones are the relevant for embedded software development or safety critical system, automotive and aviation. Now, one of the things I think for integrated, solution, I would more prefer on the TDD approach, like the test-driven development, because when you're working on something like, say, aviation industry, lots of test cases are there, and it is not actually possible to, uh, uh, do it in real life. For example, lots of test scenarios are there. You can actually generate those tests, uh, in a controlled environment. So definitely the approach should be like you do it more, like using mocking or faking, this sort of technique. You can actually kind of like simulate those situation and test your system. So my suggestive practices should be test-driven development. Definitely, you do your code review and refactoring. That's the most common thing, and also pair programming, because it's always good to have a pair of eyes, extra pair of eyes for the development part. That's interesting questions. Does TDD stop refactoring? I don't think so. TDD actually helps refactoring. So if you look at the whole TDD part, the refactoring is like, if you think refactoring as an extra event, like it will take end of the sprint or somewhere, say once in a month, where all the team members will come and do refactoring, maybe the TDD will actually kind of like stop that particular event, because when you are doing this in a regular basis, red green refactor, you're actually doing fixing lots of things. But still, I will say that you can still go there like as a refactoring event, where all the teams will actually suggest you to do something better, or how to kind of like improve your code, or how to actually improve your test cases, maybe like the TDD code that you're writing, everything. So I should not say it will stop refactoring, but maybe previously you used to have, say, 1 or 2 hour code review a week, but it will definitely reduce a little bit, because you are also refactoring while you are doing the TDD. In a Scrum team, when developer and tester are working together to build functionality, will it be considered pair programming? I should not consider it as a pair programming, because whenever we are having pair programming, we actually think that, okay, it's a developer, or it's a QA person working together. So because when a tester is working with a developer, that's more about collaboration, understanding the acceptance criteria, how things been done. It's not like that QA person can understand the complex logic or complex codes that's been written by the developer. So I should prefer that the whole, QA part, developer part will be managed by another developer. For example, 2 developers working together is actually considered as a pair programming, rather than 1 QA and 1 developer. Again, if 2 QA is working together for writing test cases, that is actually pair programming, because when they're writing these scripts for automated test, if 2 QA works together, this will be actually pair programming. They can understand each other, they can actually fix each other mistakes, suggest something, and that's actually a pair programming. But 2 different expertise working together, I should not consider as a pair programming. So anything else? Any more questions? I think we are great. So thanks, Ravi, for your questions. So if we don't have anything, so I think we can actually, finish the session. And if you have more questions, I will ask Ishan to actually share the presentation and my email address to you guys. You can reach me through email or LinkedIn, the way you guys prefer, and ask me question. Okay, guys. So thank you. You guys have a good night, and have a great day. Bye-bye.